The big question right now is mathematics getting solved by AI? We have this amazing AI progress, and even looking at some of the benchmarks or what GPT 5.2 is doing, you can see that there's amazing research boost. From open Erdős problems being solved in number theory, of course, the easier ones, to actually proving lemmas in modern day research and formalization results, so formalized mathematics in Lean. We're getting a lot of different outcomes from those models, from GPT-2, 5.2, from Gemini 3.1, also from Opus 4.6 from Claude. So there's a lot of things happening, and we're in a very interesting spot. So in this video, I'm going to show you my perspective, why I think it's absolutely amazing, and I think we're going to see the boom in research. And as a mathematician, if you're doing your PhD, if you're thinking of doing your PhD, I think it's still the best way to go into the program. Maybe not because you will be a mathematician, but maybe because your skills, so formal reasoning, will be super useful in AI in the future. Because academia is definitely going to change. How mathematicians are doing research is going to change, especially if you look at the exponential progress we're now having. So if you didn't know, there's this frontier math benchmark where there are multiple tiers, but basically if you look at a couple of tiers, especially the highest tier, number 4, you can go out to sample problems. They don't have everything open because of course they don't want to have those problems included in training data sets for different models. Then you can see that those models are definitely hard. Here you can, for example, see a problem for tier 4. I think there was this one might have been created by Bartek Naskręcki from Poland, and this particular one is pretty complex one. There are many different ones that definitely are on the verge of research but are being solved. Maybe those are cases of conjectures, of particular conjectures that are understood already. So those are those kind of problems, and machines are getting better and better on those. You can see current performance that's going up to now. Basically, you can see especially the recent passes. So for example, just I think yesterday GPT 5.4 came about, and you can see that those are able to pass close to 40% of problems. So this is pretty amazing already. And those are the problems that mathematicians were expecting to not be solved for a long time. You could, for example, have this opinion from Igor Pak saying that in the batch of problems that I looked at, some of them will be solved within 5-10 years, and some AI might not be able to solve for the next 50 years. So some of the problems, this is Ken Ono speaking, another very well-known professor of mathematics, some of the problems we were writing we can barely solve ourselves. And so it's with great anticipation that I hope that the AI entities can't get any of them right. I hope they get 0. And another one, Tao anticipated, so that's Terence Tao, one of the well-known Fields medalists, very well-known mathematician. Terence Tao anticipated that the benchmark would resist AIs for several years at least, noting that the problems require substantial domain expertise and that we currently lack sufficient relevant training data. And this is very interesting, like this point of about training data. We don't have the training data, but those models are able to figure more and more stuff about that. So I think that's pretty interesting. I was writing just about another thing that's very, very cool. So there are more and more models coming that are able to auto-formalize mathematics. Also, this is what I'm doing at my company, ulam.ai. We're building this open source mathematical prover, auto-formalizer that basically you connect. This is basically like OpenClaw, but for mathematicians. You connect that to your CLI of choice, like you connect that to Codex, from OpenAI, you connect that to Cloud Code, and it's able to start formalizing in Lean or proving new theorems. So check it out. And this is what came from another such product called Gauss by the company named math.inc. They actually formalized sphere packing problem in dimensions 8 and 24, and this is a big deal because this problem was awarded a Fields Medal a couple of years ago in 2022, and basically the formalization took 200,000 lines of code, which is also another big stuff. So of course there's a lot of work done by humans. There was a blueprint also where Wiazowska, so the original author of the proof, collaborated with, and that started as a very human enterprise, but at some point there were more and more AI autoformalization, and the final push came from AI. And this is only the beginning. There are more and more articles of people talking about how you basically have well, it might be a little bit sad that the world of mathematicians is changing from this looking at the board with chalk in hand, thinking about the problems or spending a lot of time, tomorrow being with the computer, going back and forth with AI for a longer period of time in order to do something. But this is the reality of what's happening. There are a couple of interesting papers and articles that came out just last week. One of them is from Don Knaff. So this is Knaff is of course a very well-known computer scientist. One of he's I think 80 something right now, and the article basically starts with shock. I learned yesterday that an open problem I've been working on for several weeks had just been solved by Claude Opus 4.6. This is the problem he's talking about is a problem about graphs, but the problem came up while he was writing about Hamiltonian cycles for future volume of the art of computer programming, and basically Claude Code to some extent one-shotted it, or at least maybe not one-shotted because there were multiple runs and empirical discoveries, and then actually Knaff was able to look at it and infer the general solution to the problem, which is also very cool, and he basically called it Claude's cycle, the entire concept. Another cool article is actually about this one. There was a very well spoken in article from Avigat's essay "Mathematicians in the Age of AI," which also were talking about this formalization problem that I've just mentioned, the need for the humans in the loop right now, and how it's maybe more sad right now, maybe that there's more focus and more focus on actually AI work, and it's more interested to look at the AI work than the humans work. But this is how it's changing. So it's kind of like trying to tackle this shifting world and shifting narrative from how mathematicians are important to how much AI is important, with maybe mathematicians in the loop. But there's a very important paper, and this is why I'm pretty optimistic in general. Coming from Demura. Demura is one of the creator, well, or at least the core creator of Lean. So this is the language, the programming language that allows you to verify formally mathematics. And when we're talking about formalization of mathematics, we are translating that mathematics into Lean. So Demura is talking about how large language models, of course, have amazing growth, amazing potential, and it's only to grow harder and faster. But what's really problematic is actually verification of the narrative. So it's not about hallucinations. Those, of course, happens as well, but those models are sloppy sometimes. They can make errors just like humans do. This is okay. The problem is that if you produce content at scale, be that research, be that articles, you want to have some kind of a verification process. Usually how it worked in mathematics and in other scientific domains was that you were able to, well, you had a human in the loop because you have a peer review process. You submitted your article to a journal, someone reviewed that, and then you had the argument verified. But if we have so much abundance of research that you can't really verify that manually, you need to have something in the loop to really do it. And the way to do it is actually through formal verification. This is where Lean language comes into play, and there are a couple of other languages here that are interesting and can do the same. And basically, Demura draws this basically tells you about how it's important for the future of AI as well. And I totally agree, because this is some kind of like to make this kind of reasoning even better, to not have these models to go in the loop and just have this cycles of deteriorating with with their reasoning. You need to have some kind of very hard facts verification, and Lean verification is probably one of the best ways we know about it. So again, as a mathematician, if I were to start my career now, I would definitely be looking at, first of all, you probably would have to pay for the highest grade model, meaning that from what works the best for me is right now ChatGPT Pro, the $200 per month. But even if you pay for the basic for the $20, there's a huge difference with that against the free account, and you really should try with at least $20, see if that works for you, and then pick their extended thinking, because that's the most important stuff, because OpenAI is actually able to think for longer than 20 minutes, and that thinking period gives you a lot of interesting perspectives, and this is how it's able to solve harder problems. So definitely, if you're starting as your career as a mathematician, go into AI tools head on. You should be testing that. This is a very interesting point in time. Second of all, look at formalization, because this will be a very big thing, and definitely you should be experimenting with writing your own code. You don't have to even know programming at this point. The cool stuff about that, you can just install Codex or Cloud Code in your terminal wherever you're working. If you don't know what's that, Google it, or just ask ChatGPT about it. But this is the way to start. You can start it this way and then grow and start coding. A lot of coders already are talking about the software engineers that they don't look at the code, they just write in prompts and then have Codex or Cloud Code review the code for them. And the crucial thing here is, if you want to do it well, you have the skill set, because the skill set here is pretty much the same as if you were a software engineer, meaning that you're able to solve the problems, you're able to find interesting hypotheses that you want to test, you're able to test those hypotheses. Those are the most important skills in the world of AI. Because even if AI can solve everything, if we imagine AI as a magic wand that can solve absolutely everything, then still you need you need to prompt it and basically guide it into a good direction of what's really interesting. So yeah, I'm pretty optimistic for the future of mathematicians, even though they themselves might be a little bit confused at this moment in time. But definitely the job itself is changing. Research is changing. This is coming for all of the other scientists as well. Of course, people doing physics, biology, chemistry, and so on, AI as well. But it's all changing. But there's a new, brighter future, and I think this is going to be amazing. So thank you for watching. Subscribe to the channel, have a look at my company, and see you in the next video.